Alright, so in this video we'll go over, we'll do a problem of calculating the poles and zeros. So in the last video I had mentioned whenever h of z evaluates to 0, that's when you get a 0, and when this evaluates to infinity, that's when you get a pole. So how you can determine is, when, say if you have a function and if it's a fraction, so say if it is a over b, so this will be 0 when the a part basically evaluates to 0. If the b part evaluates to 0, that means it's undefined, right? So this is how you can kind of calculate the zeros and the poles. So if you know if the if the numerator is going to be 0, that means it's going to be a 0, and if b is going to be 0, so it will be a divided by 0, which is infinity. Basically you're dividing by something extremely small, so you'll get something extremely big, which is infinity. So that will be the poles. So now with that, let's try to solve a problem. So let's say we have h of z equals to 1 minus 2z to the minus 1 plus 2z to the minus 2 minus z minus z raised to the power minus 3. So let's say we have this function. So it's really hard to kind of evaluate since we have negative powers. So if we really try to solve this, if we try to evaluate this, if we try to do h of z equals to 0, it will be really hard to solve. So what we can do is we can multiply this by the highest power, highest negative power that's already here. So in this case we have minus 3, that's our highest negative power. So if we multiply and divide both this h of z by the highest power, we could get this to be non-negative powers. So I'll show you how we can do this. So this is same as saying 1 minus 2z minus 1 plus 2 to the z minus 2 minus z to the minus 3 multiplied by z to the 3, but we can't just multiply it. This is not the same thing as this, so we must also divide z to the minus 3. So now in this case we are multiplying and dividing both. So what we're going to get is, we're going to get z to the cube in denominator, and we're going to get 1, we'll multiply this, so we will get z cube times 1 is z cube, then z cube minus times minus 2 raised to, times z to the minus 1 is minus 2z square, since minus 1 plus 3, that's 2. Then we'll get plus 2z minus 2 plus 3 is 1, and then we'll get this is z, so we'll get minus z minus cube, so we'll get minus z raised to the power 2. Wait, I'm sorry, this is minus 3 plus 3, so that's really 0, and so anything raised to the power 0 is 1, so we can just cancel this out and call this as minus 1. So this is what we will get. So just by looking at this right now, we can tell we need to evaluate this, the numerator to 0 and the denominator to 0. So the denominator is kind of simple. We have z cubed equals to 0. So if we do on the side, let's do this on the side. So if we do z cubed equals to 0, we are going to get 0, 0, and 0. Since it's raised to the power 3, we will get 3 values. They will all of the 3 z's will evaluate to 0, and these are basically the poles. If you remember, we calculated the pole by equating it to infinity, and in this case is the denominator. So when the denominator is equals to 0, the whole function will become infinity. So these are the pole responses. So in this graph again, these are the 3 poles, they're all at 0. And now let's try to evaluate the numerator. So the numerator, we have z cubed minus 2z square plus 2z minus 1. So this is really just z minus 1 times z square minus z plus 1. If you try to factor this out, you're going to get this. And then now this is in a much solvable form. So now from this we can get one root. This will be of 1 0. This will be at z equals to 1. And then we try to evaluate this. So if you notice in this case, this is a quadratic formula, and if we do the b square minus 4ac we are going to get negative. If we are going to get a negative number, we are going to get less than 0, since b here is -1, and for a is 1, z is 1, c is 1, so we're going to get a negative number here. So when we actually evaluate this, we'll get imaginary numbers, and then the numbers we are going to get will be e to the j pi over 3 and e to the minus j pi over 3. So these are the three numbers we will get, and these are basically the zeros in this case. So these three are what we will call, at these locations we will get no frequency can basically go through, and because of this property that no frequency can pass through at the zeros of this h of z, this is also called as the nulling property, because it won't let anything go through. It won't let any there won't be any gain in the frequency. And yeah, this is how you calculate h of the poles and zeros if you are already given a function.